Okay, so we're going to look at the image here. So if we were to graph this, so I had a mistake earlier because I was thinking of the wrong function. Okay, if I input in 0, I get out this is f of 0 equals 1, right? And then if I input out, so that's going to be 1. And if I input 1, my output's going to be 2, right? Which comes from the fact that f of minus 1 equals 2 equals f of 1, so that's also in there. And then if I put, so these should all be in purple, right? So those are coming from, if I was actually graphing this, this would be here, and then we would have blue points here and here, right? So this is going to show up as purple, this is going to show up as purple, and then if I put in, okay, so then I went and I put in 2, then I would have to go up 5, so 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, so then I'm going to have f of 2, and this is f of minus 2 are going to give me this, and these are both going to be 5. So I end up with a 5 here. And I can keep on going like that, okay? So you can kind of think of this as what happens if I took this as my graph, right? So the blue here, what I have is the blue is kind of like when you're used to writing y equals f of x, okay? And then if I kind of shadowed those and I just kind of projected each of these dots onto here, that would actually end up being the image, which is everything I actually hit. Okay, great. So now I'm going to look at, so this is fine, this is a subset of R, okay, and this is going to end up being minus 2, 0, and 2. So why is this? This is since f of minus 2 equals 5, f of 0 equals 1, f of 2 equals 5, and no other elements of z are mapped by f to either 1 or 5, okay? And no other elements of z are mapped by f to 1 or 5. Okay, so there's another way we could have actually done this. So here would be another way. So we could find if we wanted to take the inverse, right, again of this set, okay, this is one of, we were kind of doing these in dark green before. So if I wanted to take the pre-image of that set, okay, one of the things I could do is I could set, so I'm going to take this kind of output here, and I'm going to set that equal to these possible outputs of 1 and 5, okay? So I could set, by setting, so I could look here, and I could set x squared plus 1 to equal 1, right? So that one there, and then I have x squared plus 1 could be 5, and then solve for x. And you would get the same thing. You'd still get that your output, the only minus 2, 0, and 2 are going to get mapped to 1 and 5. Okay. Great. So we're going to do one more example, and then I would recommend you actually looking at the well-defined video. Okay, so we can also define functions. By just saying where each element of the domain goes. or where it gets mapped to. So here's an example. So I could write, so I'm going to say L is going to go from 1, 2, 3, and then it's going to go to the set red, yellow, blue, and black. And I'm going to say it's going to be defined by and then I can just kind of list here. I'm going to say, so I'm going to have L of 1 is going to be blue. L of 2 is going to be yellow. And then I can say L of 3 is also going to be yellow. That's perfectly fine. That's still a function. It's just not injective. Okay. And so in my picture here, if I kind of think about this, so I have my domain, right? So this is my domain. So I'm going to have, this might feel a little funny, but so I have a set 1, 2, 3. This is not normal set notation to do it like that, but that's what we're going to do. So we have domain is over here, right? This is going to be our codomain. So our domain is going to be the set 1, 2, 3. Our codomain, right, so this here is our codomain, right? So our domain came from here, that was our codomain. Okay, and then I wrote this over here. So I have red, this is just kind of another way to organize your thoughts. And this is blue, and this is black. Okay, and what does L do? I look here, it sends 1 goes to blue, 2 has to go to yellow, and 3 has to go to yellow. I do need an arrow coming out of each thing over here. I do not need, an arrow hitting everything over here, that's okay. It's also okay that I have 2 arrows going to the same thing. Okay, so if I'm going to kind of summarize kind of what I have so far, I have that the domain is equal to the set 1, 2, 3. I have that my codomain is equal to red, yellow, blue, black. Okay, the other thing is, so if I look here, the only 2 things, right, that are actually hit by L are yellow and blue, so my image is actually going to equal blue, yellow. So something to note here is that I'm only going to include this once, even though it's repeatedly in the image. Even though it shows up as an output more than once. Okay? Now, what if I wanted to take L inverse of X? Okay? So, now I'm interested in figuring out how to compute L inverse of X. Well, I can start organizing my thoughts first, and I can notice that, okay, so yellow, what gets mapped to yellow? 2 and 3. Okay, so for any X containing yellow as an element, we're going to have, right, that both 2 and 3 would have to be in there. Okay, and that's going to be useful for us to keep track of. And then we can say a similar thing here. So for any x containing, but now we're looking at blue as an element, we have, so now we have that 1 has to be in there, right? Because 1 is the only thing that actually maps to blue. But 1 does map to blue. Okay, so now let's kind of look at various different sets. Oh, I actually have room over here. So if I wanted to look at, okay, so I'm going to use these two pieces of information, and if I want to take L inverse of x of, now I'm going to look at the set, sorry, I wrote this incorrectly. I meant to say I want to take, so x is going to be the set that just contains black. I look here, nothing maps to black, and so I get the empty set. And then if I want to take L inverse of yellow, or the set just containing yellow, I can look, well, what gets mapped to yellow? Just 2 and 3. And we kind of got that from there also. So this is just 2 and 3. I can keep on going. What if I put red and yellow? Okay, well, nothing mapped to red, so that doesn't actually add anything. I still just need to look at what mapped to yellow, which would be 2 and 3. Okay, let's try red, blue, and black. Okay, so here I would get this set just containing 1. Okay, because I looked at red, blue, and black, nothing maps to red, nothing maps to black. I look at blue and 1 map there. Okay, and then my last one, so I have L inverse. So I have red, yellow, and blue. And if I look at the previous, so I'm going to get 1, 2, and 3. Okay, so how did I get that? So I'm looking at red, yellow, and blue. Red, yellow, blue, nothing maps to red. 2 and 3 map to yellow. 1 maps to blue, so I needed to include 1, 2, 3. Okay, thank you very much. And I hope that you got a lot out of this and that you'll also take a look at some of the other videos.